Hi everyone, welcome to this channel. We are studying science of class 9. In that we are studying chapter 8 motion that comes under physics part. I am Abhishek sir and let us start our journey. Before we start with the third video, let us see which topics we have studied in the first two videos. In the part 1 video, we dealt with introduction, types of motion, describing motion, distance, displacement, uniform and non-uniform motion. So that was our first video, introduction video. So we studied and discussed about the basic concepts. In part 2, we discussed rate of motion, speed and related terms, then we studied velocity and related terms, and then we also studied and solved few numericals. So I hope these two parts were useful to you, and in this break also you might have gone through these two videos. So assuming that you are having this knowledge, let us start our part 3. Now let us see what we are going to study in this short part 3 video. In this part 3 video, we are going to study about acceleration. This is our new term. We'll see definition, formula, unit. Then we will see types of acceleration and we'll see various sums. Now, the concept of acceleration lies in the type of motion that we have studied, uniform and non-uniform. So let us understand why we are studying acceleration. How motion is related to acceleration. Okay, so you see, in uniform motion, speed or velocity remains same at different intervals, right? In uniform motion, speed and velocity remains same. Okay, so can we say that, so we can say that speed velocity is same at different intervals. That means velocity or speed remains constant, and whenever anything is constant, that means there is no change, right? So the change is 0. Clear? Change in what? Change in velocity at different intervals. Clear? Now let us move towards non-uniform motion. So in non-uniform motion, speed and velocity changes with time. Okay, so that means they are not constant, they remains changing. Either they increase or either they decrease. So the changes with time must be measured. Changes in speed and velocity must be measured. These questions, how much change, whether it is increasing or decreasing, so these questions can be answered by finding a physical quantity that is called acceleration, right? So what is acceleration? Acceleration is the change of velocity or speed with respect to time, right? Whenever you drive a vehicle, you have the accelerator in your vehicle, right? So what does accelerator do? It increases or decreases your velocity. Suppose you started the vehicle, and now your velocity, even though it is 0, now you want to move. So what you do? You give accelerator. Clear? So that accelerator will increase your speed or velocity. Suppose you are traveling at a speed of some speed, right? And now your home is near. So what do? You decrease the accelerator. Clear? So in that case, what happens? You release the accelerator and your vehicle will stop after some distance. That means your velocity decreases when you release the acceleration. Clear? So accelerator in the vehicle and acceleration both are related. Clear? In vehicle, what do? We do acceleration. Clear? So now let us see in detail about acceleration. Now let us start with the main topic, acceleration. What is acceleration? It is the rate of change of velocity. Now whenever we speak about rate, that we have to include upon time, right? So define acceleration, it will be rate of change of velocity or change in velocity per unit time. Clear? That is acceleration. Acceleration is denoted by small a. So wherever we are using symbol or formulas, you will represent acceleration with small a. So in words, the formula of acceleration is acceleration equals to change in velocity per unit time, right? But we are not using every time formula in words. So let us go for the words. Instead of words, let us go for the symbolic formula. But to find change, we need to suppose initial and final, then only we can find any kind of change, right? Suppose you want to find change in your result, so you have to compare it with the latest result with the previous result, right? So initial and final are necessary whenever you want to find out change. Here we are finding change in velocity, that is why we must suppose what was the initial and what was the final velocity. Now, assuming that u is initial velocity, v is final velocity, and t is time. So, acceleration a equals to v minus u, that means final minus initial upon time. Clear? So, this is the original formula of acceleration. A equals to v minus u by t. Whenever we will solve numericals related to acceleration, we will use this formula. Clear? Now going for the unit. Now in the numerator we have velocity, so change in velocity. So even if you find change, ultimately unit will be of velocity, that is meter per second. In the denominator you have second, right? Now this second is in denominator, meter per, so this second will go with this second. So ultimately it will become meter upon second into second, that means meter per second square. Clear? So this is the unit of acceleration. Clear? So we have seen definition, word formula, assumption and symbolic formula and the unit. Clear? Now let us see how many types of acceleration are there. There are two type of classification, right? One is positive acceleration, another is negative. As I discussed that if you are starting your journey, so what you will do, you will increase your velocity. So you will accelerate, that will be positive acceleration. Okay, but when your destination is near, you will release the accelerator, that means acceleration will be negative, right? So let us see further what is that two concept. Now there are two types or two cases that we can say. First case is very normal, when velocity increases, right? That means the final velocity is greater than the initial. In that case it is said to be positive acceleration, acceleration will be positive. Clear? Now the second case is when velocity decreases. In that case the final velocity will be less than initial velocity. So v is less than u. So in that case acceleration will become negative, and we have some special words for negative acceleration, that is retardation or deceleration, right? Negative of acceleration is called retardation or deceleration. When you will solve sum, make sure that whenever retardation is there, acceleration value will be minus, negative. Okay, so these are two cases when velocity increases, positive acceleration; when velocity decreases, negative acceleration, that means retardation. Okay, now let us see the types of acceleration. Now types of acceleration is, first one is uniform acceleration. So notice the word uniform. When an object is traveling and its velocity increase or decrease, right? If the velocity is increasing or decreasing uniformly, that means equal distance in or equal velocity increase in equal interval of time, then it is said to be uniformly accelerated. Example, freely falling object and a ball rolling on a slope. You can see when a ball rolls on a slope, the velocity increases or decreases uniformly. So it is the acceleration in that case will be uniform acceleration. Moving on to the second part, that is non-uniform acceleration. So that will be totally opposite of uniform. So when any moving object changes its velocity non-uniformly, that means unequal velocity changes in equal interval of time. so then the acceleration is said to be non-uniform. For example, if you are moving in a car or any vehicle in a crowded place, that means your velocity of the vehicle will not increase or decrease properly. So sometimes it will be more, sometimes it will be less. So it is non-uniform. So acceleration of the car in crowded place can be called as non-uniform acceleration. Clear? So we have discussed types of acceleration and all the theory related to acceleration. Now let us see few practice examples by which we can solve the problems of acceleration. So let us start with the first practice sum. A vehicle starts from rest and achieves velocity 36 km per hour in 5 seconds. Find the acceleration. So before solving any kind of word problem, I have told you what to do to prepare the given list. So what first is given is velocity, and you see starting from rest and then achieves, that means initially the vehicle was at the velocity 0 meter per second. Note that rest word is very important. Now final velocity given is 36 kilometer per hour and time given is 5 seconds. Now it is very important that we must follow the SI units, standard units. So what we will do, we will convert this 36 kilometer per hour into meter per second. Clear? And previously also we have discussed, like if you want to convert meter into kilometer, so how many meters in 1 kilometer? 1000 meter upon how many seconds in 1 hour, that is 3600, that is 60 into 60, right? Now let us cancel the zeros. If you cancel these two zeros, we will have 36 into 10 upon 36, and we know that 36 ones are 36. So final velocity 36 km per hour in meter per second is 10. Clear? Now let us go for the formula. Acceleration A equals to V minus U by T. So putting the value of V, that is 10, U is 0, time is 5. So that is 10 upon 5. Ultimately the answer will be 2 meter per second square. Don't forget the proper unit. So that is the simplest problem of acceleration. Now in this chapter, whenever you will solve sums related to acceleration, it won't be very easy like this, right? So we will have to see some complex numericals in which more than one cases are there. Here it was only one case, right, from rest to 36. Okay, so let us see next example given in our textbook. Now see example 8.4. It is given after the topic of acceleration, right? We have only one example that is related with acceleration, then next topic starts. So let us see this example in detail and then I will give you few practice questions. Now whenever you see a big numerical, you are so worried, right? But I will suggest that the first step is the most important. What is the first step to solve the numerical? To make the list of given. Clear? If you are making the list of given and you are knowing the formulas properly, you will understand how to solve the numerical very easily. Okay, so let us see the keywords starting from stationary position. So initial velocity 0. Clear? Rahul pedals his bicycle to attain velocity 6 meter per second in 30. So final velocity he attains is 6 meter per second, and what was the time taken? 30 seconds. But the question is not over yet. We have second case as well. So after all this, we have to find out acceleration. Then in the second case, what happens? From 6 meter per second velocity, he applies brake. And we know when we apply brake, the velocity reduces. So from 6 meter per second, velocity comes down to 4 meter per second in the next 5 seconds. So calculate acceleration in both the cases. So consider this as our case 1 and this as our case 2. So we will find acceleration how many times? 2 times. So this is for case 1, and let us also make a given list for case 2. Understand that case 2 initial velocity was 6 meter because he has come from 6 meter to final velocity 4 meter per second. So this will be the initial, okay, for case 2, and for that now the time taken is 5 seconds. Clear? So we have to find out acceleration in both the cases. We have everything, so let us go for the formula. So again, starting with the formula A equals to V minus U by T. Before putting the values, check whether all the units are standard or not. So we are having meter per second and second, so all set. So velocity V equals to 6 stationary, so 0 upon time 30, right? So it will be 6 upon 30. You can cancel 1 upon 5, right? 6 1s are 6 and 6 5s are 30. Clear? And 1 upon 5 can also be written as 0.2 meter per second square. Don't forget the unit. So first answer we already got. Now let us start from the second answer. Now velocity is decreasing, so this is a case of retardation. Clear? Let us see if acceleration is negative or not. So here velocity decreases from 6 to 4. So final velocity is 4 minus initial velocity is 6 and time taken is 5. Clear? So 4 minus 6 is minus 2 upon 5, and you know minus 2 upon 5 is 0.4. Don't forget the unit, meter per second square. So here we have our answer. If you write is A1, write this as A2. Clear? So that is how you will find the acceleration in both the cases. Clear? So in only one single numerical, two different cases were discussed. So that's all for practice sums. Now in the next few seconds you will see few questions that you have to solve after this example solution. So best of luck, and I hope all of you might be able to solve it. If in case you have any doubt, re-watch the video and then apply the logic and formula. So here are your practice questions. So two questions are there. First is velocity of a vehicle increases from 5 meter per second to 15 meter per second in 5 seconds. What is the acceleration? So initial is given, final is given, and time is given. Clear? Use acceleration. Second question is velocity of a car with 72 km per hour reduces to 18 km per hour. Velocity reduces, right? So this is initial, this is final, and time is also given. Find its retardation. So retardation is negative acceleration, so you are finding acceleration only, but your answer will be in minus. So that's all for today. I hope you will be easily able to solve this. All the best. See you soon in the next part.